Okay, this lesson is just to give some tips about drawing straight line equations. So if you see an equation in the form y equals mx plus c, so for example y equals 3x plus 2, those are the easiest ones to deal with because in that form the number in front of the x, the m, is the gradient, how steep the graph is, and the number on the end, the plus something, or it might be minus something, is the intercept. That's where it cuts the y-axis. So, for example, if I've got this one here, y equals 3x plus 2, let's just write that down again, y equals 3x plus 2. So there are my axes, x across, y vertically, scaled with some values. Don't have to draw in every value, just enough to give you a sense of how big everything is. Y equals 3x plus 2. Because of the plus 2 on the end, then I know that that graph is going to cut at 2 here. The intercept is 2. And then because of the 3x, that tells me that the gradient or steepness is 3, which means that for every 1 across, it goes 3 up. For every 1 across, 3 up. 1 across, 3 up. And then back the other way as well. 1 and 3, 1 and 3, 1 and 3. If I was doing a big graph, I wouldn't be thinking in 1s and 3s. I'd maybe be doing 10 and 30. But the ratio is the same for every 1 across, 3 up. So that's the graph of y equals 3x plus 2. And then for good measure, we should label the graph with its equation. So there it is, y equals 3x plus 2. Okay, so we'll just do another one of those. Let's say y equals, put the right pen there, y equals 2x minus 1. So the minus 1 is telling us that it's cutting at minus 1 there. And then the 2x is telling us that for every 1 across, it's going to go 2 up. So I'll just get my line here. And then 1 across, 2 up, 1 across, 2 up, 3 across, 6 up. Why not? 1, 2, so it's there. And then back the other way, 1 and 2, 1 and 2, 1 and 2. So there's the graph. Y equals 2x minus 1, cutting at minus 1, and with a gradient of 2. For good measure again, I should label that with its equation. So I'll just take that and resize it and put it over there. And there it is, y equals 2x minus 1. We'll do another one like that, but this time we will make it y equals minus x plus 4. So when you see just x on its own, it's like 1x. So that's like having y equals minus 1x plus 4. So it's going to be a graph that cuts at 4. And then the gradient is going to be minus 1. So for every 1 across, it's going to go down by 1. So there we are at the start again. 1 across and 1 down, 1 across, 1 down. I might as well go 5 across and 5 down. 2 across, 2 down. And then back the same the other way. There we go. Get that in the right place. 1 across, yeah, down there, isn't it? Okay, so cuts at 4, and then because the gradient's minus 1, then for every 1 across it goes 1 down. Again, I'll just label that. I will need to rub something out here, get rid of that. And then label the line for good practice with its equation like that. We'll do one more and then we'll take a couple of different types of example. Okay, so y equals minus 3x minus 2. Okay, so the minus 2 on the end is telling us cut at minus 2. And then the minus 3x is telling us that the gradient is minus 3. So for every 1 across, 3 down, and then back the other way, 1 and 3, 1 and 3, 1 and 3, 1 and 3, and so on. Okay, so a gradient, a line with a gradient of minus 3, so sloping down from left to right, and then 1 across for 3 down, and cutting at minus 2. Label that again for good measure. Where is it? There we are. Boom, 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 like that. Okay, now occasionally you might see one like this. 3x plus 4y equals 12, for example. Now, you could try and rearrange that as y equals so many x plus something, so it looks like a y equals mx plus c. But I think there's an easier way to do these ones. If you think about what happens when x equals 0 and y equals 0, so when x equals 0, you get 0 plus 4y equals 12, so y has to be 3. When x is 0, y is 3, so that gives us a point on the graph, 0, 3. Now in the same way, we can think about when y is 0. When y is 0, we would get 3x plus 0 equals 12. So 3x would have to be 12, x would have to be 4. So that gives us another point on the graph, 4, 0. When x is 4, y is 0. And since we know it's a straight line and we've got 2 points on it, we can just join those 2 points up, and there's the straight line graph there of 3x plus 4y equals 12, which I will just label again for good measure. Let's just get rid of all this stuff. That's not going to go easily, so I will just label it again, write it down here, 3x plus 4y equals 12, and then just take that label. It's not even going to let me do that, is it? Okay, well let's write it directly on. 3x plus 4y equals 12. Okay, 2 more examples. Special cases. When you get y equals a value or x equals a value. So for example, the line of x equals 4. So that's the straight line consisting of all of the points where x is 4. So for example, 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. So in other words, the line x equals 4 is just a straight line of all the points where x is 4. In a similar way, the line y equals, let's say 6, is a horizontal line consisting of all of the points where y is 6. So it's just that horizontal there consisting of all of those points where y is 6. A horizontal line going through the y-axis at 6. And then you get special cases of those. So the line y equals 0. The line y equals 0 is the horizontal line of all of the points where y is 0. Now that can be confusing because the line y equals 0 is the x-axis. And in the same way, the line x equals 0 is the y-axis. So be careful not to be confused by that.